Alright, today we're just going to do a very quick short video. Try to keep it as short as I can without blabbing on forever. We're going to cover pressure switches, pressure senders, and temperature senders and switches for that matter, and how to bench check them. Alright, now why would you want to bench check something like this? Well, could be various reasons. Sometimes get new parts and you just like to check them out before you install them. It's not a bad idea to put them on the bench and check them before you go and install them. New parts do occasionally come bad from stock, new from stock. So you can bench check it. That's not a bad idea, although it's not always necessary. It's not unusual to assume that new parts are good, but it's not always true. So another reason would be you have a suspected bad part and you have already removed it, but you've already got one ordered. Well, one good thing to do in electrical troubleshooting, electromechanical troubleshooting, is to double check your work. So if you troubleshoot something, let's say a generator that keeps shutting down, all right, and you think it's a pressure switch, oil pressure switch, that is causing the system to shut down, you can short the wire from here to here. You disconnect both wires and just short them together and see if it continues to run. Well, you've shorted it and it continues to run and it doesn't shut down, so you assume, oh, it's got a bad pressure switch. Maybe, probably, but not always true. Sometimes the act of just going into the area and disconnecting these two things and then shorting them together is enough to make it run and mask something that was there but not the pressure switch. So one of those things can be just the crimps that have the spade connectors on here could be corroded, they could be compromised, they could be broken internally, say inside some shrink tube, and that by you disconnecting them and shorting them together for troubleshooting purposes, that you have now made contact inside the shrink tube, and then you go and it runs and it operates and you think, oh, clearly it's a pressure switch. Most time it is, but 1 out of 10, somebody that's done a lot of troubleshooting will know that 1 out of 10 or 1 out of 20, you are surprised when you get your new pressure switch in and it does the same dang thing. And you see people in the forums all over, say Facebook and things, like on the generator forums or this or that, saying that they've already replaced this component or that component and that's not it. Well, one of the ways you can avoid having to buy new components, especially these type of components, is if you can bench check them. So you've done your troubleshooting, you shorted the switches, you're confident it's the pressure switch. Well, take this home, get a little rig like this. This is just a Harbor Freight pressure regulator, some shop air, which you don't need anything crazy, just a little pancake compressor, or even like a little tire servicing compressor would probably do it if you could rig it up. A couple clamps, a hose, and a multimeter. Again, as I've said before, anybody that wants to operate a boat needs to have a multimeter and needs to know the basics of checking voltage, ohms, and mainly that's it. AC and DC voltage if you have AC and DC on your boat. Obviously everybody has DC, not everybody has AC. Just being able to do those are big time savers and will save you a lot of money. So anyways, let's just pretend that we've done some troubleshooting at the boat. We think it's this pressure switch, and so we're going to take it home and we're going to ops check it. So we're going to do that, and then I'm going to hook this up to the rig that we have and show you the difference between a pressure switch and a pressure sender, which is obvious to many but not everybody, and then see how a temperature sender behaves and reacts when bench checking it, what it looks like. Alright, let's set it up and we'll do that. Okay, so we've got the pressure switch clamped onto this hose. We've got our regulator. We've got our two clips hooked onto the terminals, one of which is broken, which is why I'm using this one to test, but I can still get some contact on the little alligator clips. And we've got our multimeter set to ohms. So right now we have no continuity, which we shouldn't. That would assume that the pressure switch is open, the internal switch is open, which should correspond to the fact that we have no pressure in this line. So when we apply pressure, at some point on this needle, if if this thing works correctly, it should close and we should see good continuity through here. Now, how do you know what these switches are set to open at? Usually it's in the part number somewhere, like a number 15 or a 20 or a 5 or an 8, 7, you know, and that usually corresponds to PSI. Sometimes in the description when you purchase them, sometimes in the operation and description of the manual of whatever it is that you're troubleshooting, and various other methods to find out what it's supposed to. So in this case, it's marked with a 15 on there. I'm assuming that that's what this one is, but we'll see. Now also on a rig like this, if you put the pressure, start bringing the pressure up, and it closes at 14 or 18 or even 20, I would still assume that that is pretty good, or a good switch, because something like this, you have a little bit of leakage. What's shown here may not be exactly what the pressure is there within a couple PSI. So you're not really, if this is a 15 PSI pressure switch and it closes at 20, I wouldn't be too worried about it, because there's also a rising and a falling activation point. So meaning that you have to bring the pressure up to a minimum as you're rising in pressure to make it work, make it close. But then a lot of times there's a hysteresis, and as you're falling, it will close at a different point than rising. So just be aware, if it's a 15 PSI pressure switch or 20 PSI pressure switch, as long as you're getting it to activate somewhere around there within reason, that it's probably good. Now what you don't want to see is if you bring it up to pressure and it says OL, or if you have it hooked up like this and it has continuity. Another test to do is to hook it up to this pin and then take this one and ground it against the case. In this case, it's a 2-pin, so some are case grounded, and so the tests are a little bit different for ones that are case grounded. You would have the red one on that, and you would have the black one on the case ground. But in this case, it's not quite set up that way. So this is an isolated switch. So anyways, we're going to raise the pressure and see what happens. So watch here, and I'll slowly turn it up, and we'll wait for an activation point right there. So let's do it. Let's see if we can get off. It's off the needle now. It's at 1. That's about 10. Nothing yet. About 15. About 18. About 20, just about 20. Oh, what's that? Looks like about 23 or so. We've got 1.2 ohms, 1.1 ohms. That's pretty good. Dropping to 1 ohm. So we have good continuity. Let's back it down and see where it shuts off at. Okay, so right about 20. So it closes around 20, opens around 24, closes around 21 roughly. So this is a pretty good pressure switch. It only has about a 2 or 3 psi swing in the rising and falling activation points. Cheap ones and ones that aren't well designed have a pretty wide swing. Now when you run this, you're assuming that pressure rises, and then that's how you'll be operating. So the voltage that keeps, say, a generator fuel lever solenoid open travels through this pressure switch. So your generator is going to run until you lose oil pressure, and then pop, the switch opens. Your fuel solenoid no longer gets voltage, and the engine shuts down. So really what counts here is the falling pressure, which we're going to say is right around 20. I'm pretty sure that said 15 on it, but I would still call this pressure switch probably good. You can hear some air leaking in there, so this pressure switch is good. Let's set up to the sender and see how that one behaves differently. Alright, so now we have our sender hooked up, and this one is case grounded. It's a 1-wire sender. So this one, when you screw it into the engine block, it will be grounded, and that's where it carries the return signal path from. So again, this one is used for, it's just a switch used for shutdown and basic engine monitoring oil pressure monitoring. This one is for a gauge that feeds a signal to a gauge. So we've got this hooked up. We've got 0 pressure on it. We've already got 241 ohms. So that will correspond to a needle position on the gauge. In this case, it should be 0. It should be resting on 0. So as we raise this pressure, you should see a corresponding change in the ohms. So let's just get it off the needle of 0 here. There it is. So we didn't see much change there, but just a little bit. Sometimes that's just getting it off the needle on the gauge as well. So let's just go right to 20. Okay, there's 20. 20 psi is 180 ohms. Let's go to 50, or I'm sorry, 30. 30 psi is 156 ohms. 40 is 120, still dropping, 121 roughly. Let's just bring it to 50. So as you see, it's a very variable and incremental change, and actually it's pretty darn sensitive. A little lagging coming back the other way, but that could be the bleed off of the pressure in the line. So we would call this good, and let's make sure it returns to roughly the same ohms. So we would call this sender good. It should be. It's brand new. It's never been used. Let's do it again, right up to 20. Now you could actually hook your gauge up to this. If you just had a battery and a wire, 2 wires, and like say these alligator clips, you could easily rig up your oil pressure gauge on here and just watch the whole thing work, and you could test the whole system, and that would be pretty easy to do. And if you had any problems with indication while on the boat and you wanted to bring it home and bench check everything, you could do the sender and the gauge all at once and see that it works and doesn't jump around and has an accurate reading and all that stuff. And if it does work, then you would assume every issue that you have is probably within the wiring of your boat. So anyways, that's the difference. This one is just open and closed. That one is a variable signal, both in resistance or ohms. The difference in this one is the ohms variance will result in different voltage signal, and the gauge will have a corresponding needle position for those different voltages when fed 12 volts. So let's check out this pressure sender and see what it does. All right, now we've got the temperature sender hooked up, and this would be for like a water temperature gauge, oil temperature gauge, whatever it is, whatever the range is. I don't even know what this one came from. I've just had it laying around for years. It's brand new. I've never used it. So we get 1.321 kiloohms. So that is essentially 1,321 ohms. So that's a pretty fine signal there. So again, that will feed a signal to a corresponding gauge position. But to test this, you would want an ice cube or a heat gun to make this fluctuate. But it should be sensitive enough if I just grab it in my body heat, if I just pinch that, and you can see it responds immediately. So this little sensor unit is actually a pretty sophisticated and accurate sensor. Usually where things fall short is in the gauge itself. So anyways, if I let go of it, now it should climb back up slowly, which it does. So all of these items are good that we tested, and if you were to have brought these home from the boat that you were troubleshooting, you could be confident that it's none of these components. It's going to be either the gauges themselves or the wiring in between. So that's pretty short and sweet. I just wanted to show this because I had all this stuff out and it was not a big deal for me to set up a rig to check it. So make sure you like and subscribe if you get anything out of these videos. The purpose of this channel is just to share knowledge. It's not to make money or to be famous. As you see, I don't even put my face in these videos most of the time. It's mainly just to share knowledge and to document what's going on with my particular boat in case I ever sell it, or I can also show family members various reasons why I like to document it. Memories, it's basically a scrapbook of the future. You know, this how memories are saved these days, in my opinion. Used to be the old scrapbook, which I have tons of old pictures, but this is the way to do it now. So anyways, like and subscribe if you like the channel. It helps grow the channel, which I would like to have happen as well, especially if anybody finds this useful. That's the main purpose. All right, have a good day.